Welcome back to AI.Code.Cast. Today, we're going to do a deep dive into image manipulation,
Okay.
specifically the rotate image problem.
Sounds fun.
Yeah, this one is it's a classic problem.
Yeah.
You see it in technical interviews a lot, and even real-world applications too.
Right. Image processing and stuff.
Exactly. So imagine you're given a square matrix,
Okay.
which is like a grid of pixels that makes up an image.
Right.
And we want to rotate it 90 degrees clockwise.
Okay.
But there's a twist.
Okay.
We have to do it in place.
Yeah, the in-place requirement.
Yeah.
That can be tricky sometimes.
They can be.
So in place means we have to modify the original matrix,
Right.
like directly,
Right.
without like creating a whole new copy.
Exactly.
And that's really important for saving memory.
Yeah, especially with these huge images.
Oh, yeah. Think about like rotating a massive high-resolution photo.
Right.
You don't want your program to just like eat up all the memory.
Yeah, that would be bad.
Yeah, it could really slow things down. Yeah.
For sure. So the big question is, how can we rotate this image without using any extra space?
That is the question.
Yeah.
Well, before we get into like the really clever solutions, it helps to think about the brute force way first.
Okay, so just like the most straightforward approach.
Yeah, just to see like what we're dealing with.
Okay, how would we brute force this?
Basically, you'd make a brand new matrix the same size as the original one.
Yeah.
And then you just copy the elements from the old one to the new one, but in their rotated position.
So like the top left corner of the original
Okay.
would go to the top right corner of the new one?
Exactly. It's like picking up each little pixel and moving it to its new spot
Okay,
based on like that 90-degree turn.
makes sense.
Now it'll work for sure.
Okay,
Figure-
there's got to be a catch.
Yeah, it needs a ton of extra memory to store that whole new matrix.
Right, because we're essentially duplicating it.
Yeah, and that's not very efficient.
No, especially for those really big images we were talking about.
Right. It could become a real problem.
Mhm. So how can we do this without needing all that extra memory?
That's where things get interesting.
Okay, I'm intrigued.
We have to work within the original matrix itself.
Okay.
It's like solving a puzzle,
Right.
like rearranging the pieces without taking any out of the box.
I like that analogy. So
Okay.
so what's our first elegant solution?
Let's start with the
Right.
transpose and reverse method.
Okay.
It's really clever and efficient.
Okay, I've heard of that one. How does that one work?
So it basically breaks the rotation down into two steps
Okay.
that are really easy to understand.
Okay.
The first step is to transpose the matrix.
Okay, what does that mean to transpose?
Imagine you're folding the matrix like along a diagonal line
Okay.
from the top left corner to the bottom right.
Right.
Transposing is like mirroring it across that line.
So every element swaps places with its mirror image.
Exactly.
Okay.
And this like simple little move is really powerful
All right.
because it puts all the elements into the correct columns
Okay.
for our rotation.
Yeah.
They're just not in the right order within those columns yet.
Oh, I see. I see. So that's step one.
Right.
So then what's step two?
So once we have that transposed matrix,
Right.
all we do is reverse the order of the elements in each row.
Okay, and that puts them in their final spots.
Exactly.
Okay, so it's a two-step dance.
Yeah.
Transpose to get the columns right.
Yep.
And then reverse each row to put them where they need to go.
Exactly. You got it.
That sounds way easier than I thought it would be.
It is.
I like it. And it sounds pretty efficient, too.
Oh, it is.
Yeah.
We're only like touching each element like twice.
Okay.
Once during the transpose and then once during the reverse.
Right.
That gives us a time complexity of O n way.
Oh, okay, cool. And
Yeah.
and most importantly, we're not using that extra matrix right.
Right.
So we're using way less memory.
Exactly.
Our space complexity is O1.
Yeah. It's a really elegant solution.
I like it.
Whoa.
So is that like the most popular way to do this?
It's one of the most popular for sure.
Yeah, it's a good one.
Mm.
Now, I'm always a fan of having different ways to solve a problem.
Right.
So is there another way we can visualize this and maybe come up with another solution?
There is.
Okay.
This next solution might appeal to the visual thinkers out there.
Okay.
It's called the layer-by-layer rotation.
Layer by layer. Okay, give me the visual breakdown.
All right, so picture this. You're peeling an onion,
Okay, I'm with you.
and you're rotating each layer as you go.
Okay.
That's basically what this method does.
Interesting.
We're going to systematically move elements in a circular pattern within each layer
Okay.
to achieve that rotation.
Okay. So if we had our 3x3 matrix,
Yeah.
the outer layer would be like the top row,
Yep.
the rightmost column,
Uh-huh.
bottom row,
Uh-huh.
and then the leftmost column.
Exactly. That's your first layer.
Okay.
And within that layer, we're going to cyclically swap elements in groups of 4.
So we're swapping 4 elements at a time.
Yep, to rotate them.
Okay.
Like if we take that 3x3 matrix again as our example, Hmm.
The top left element would
Yeah.
swap with the top right,
Okay.
and the top right would swap with the bottom right,
Okay.
bottom right with the bottom left,
Gotcha.
and then finally the bottom left with the original top left.
So each element is like moving one position clockwise.
Yeah, like a little square dance.
Ooh, I like that.
Right.
And then we move to the next layer in.
Exactly. Once that outer layer is done,
Right.
we move inwards
Okay.
to the next layer and do the same thing.
Which in the 3x3 case would just be the middle.
Exactly.
Okay, cool. I can visualize that one.
Yeah, it's a very visual approach.
And is that one as efficient as the transpose and reverse?
It is. We're still only touching each element once.
Right.
So we get the same ON time complexity
Okay.
and, of course, O1 space complexity because it's all in place.
Nice. So we've got two really good solutions.
Yep.
Both equally efficient.
Pretty much.
So is it just like a personal preference which one to use?
A lot of times.
Yeah. It comes down to which one like makes more sense to you or
Yes.
which one results in like a cleaner code
Okay.
in whatever language you're using.
Right. Whatever's more readable.
Exactly.
Cool.
Yeah.
I like that coding has that flexibility.
Yeah. It's like having a bunch of different tools and
Right,
you
yeah.
get to choose the best one for the job.
I like that. Now, before we move on, I have a question about these two methods.
Sure.
What if we wanted to rotate the image counterclockwise?
Okay.
Like, instead of clockwise,
Yeah, that's a great question.
could we tweak these methods to do that?
Yeah, definitely.
Okay.
It's actually pretty easy to adapt them for counterclockwise rotation.
Oh, okay. How would we do that?
So let's take the transpose and reverse method again.
Okay.
Remember, the first step was transposing.
Right. Swapping across the diagonal.
Exactly.
Yeah.
Now, to rotate counterclockwise, we still do the transpose,
Okay.
but instead of reversing each row, we reverse each column.
Interesting. Okay, so it's the same idea, but we flip it.
Yeah.
Yeah.
You just flip the logic.
I like that. I like that. So it all builds on itself.
Yeah. Once you get the basic idea, you can
Wow.
apply it in all sorts of ways.
That's cool.
Yeah.
I'm already feeling like I'm getting better at this.
That's great. Now, speaking of variations,
Okay.
there's actually one more way to rotate matrices
Okay.
that I think we should talk about.
Let's do it.
It uses a technique called cyclic replacement.
Cyclic replacement.
Mm-hmm.
Okay, that sounds interesting.
Yeah, we'll dive into that one next
Let's-
time.
Let's do it. Okay, so we're back and ready to tackle this cyclic replacement thing.
All right, yeah, this is where things get really interesting.
Okay, I'm excited.
So both transpose and reverse and layer by layer,
Okay.
they kind of use cyclic replacement already.
Okay.
But this next method,
Yeah.
it uses it in like its purest form.
Okay, so those other two were like hiding it a little bit.
Yeah, kind of.
And
Think back to the layer by layer approach.
okay,
We were rotating each layer,
right.
swapping 4 elements at a time.
Right, like a little square dance.
Exactly. Now imagine, instead of doing those 4 separate swaps,
Yeah.
we could do it all in one move.
Oh, okay, so like a shortcut.
Yeah, exactly. It's like taking a high-speed train instead of a local.
Right, less stops.
Exactly. You get to the same destination.
Okay, but does it actually make it faster?
From a big O notation standpoint, it's still ON.
Okay.
Because we're still touching each element once.
Huh?
But in real-world scenarios, it could be a bit faster.
Okay, because we're doing less swaps overall.
Right. Those extra swaps add up.
Yeah, so it's all about finding those little optimizations.
Exactly. Every little bit counts.
So how does this cyclic replacement thing actually work?
Well, let's stick with our 3x3 matrix.
Okay.
Remember, in layer by layer,
Yeah.
we would have swapped the top left element with the top right,
Right.
then top right with bottom right, and so on.
Yeah, each element doing its little 4-step shuffle.
Exactly.
Right.
With cyclic replacement, we cut out the middleman.
Okay, so no more shuffling.
We take that top left element and we move it directly to its final spot.
Okay, which would be the top right.
Exactly. But there's already something there.
Right. We got to make room.
So what do we do?
Well, we'd have to move what's in the top right to its final position right.
You got it. So you're getting this?
Okay.
So that element would go to the bottom right.
Right. Replacing what's already there.
Uh-huh. And then that element goes to the bottom left.
Okay. And then that last one goes back to the top left to complete the cycle.
Precisely.
Oh, okay. I see. So it's like a chain reaction.
Yeah.
Right.
Just like we've rotated those 4 elements and we
Okay.
do the same thing for the other 4 in that layer.
Right. And then move inwards.
Exactly. Just like with layer by layer.
I'm starting to see why you called this like the purest form of cyclic replacement.
It's very direct.
Yeah, it gets right to the point.
No messing around.
Although it is a little harder to picture in my head,
It can be. Yeah, it's a bit more abstract.
but sometimes those are the most elegant solutions.
Oh, for sure.
It's like a really clever trick.
Exactly. And once you understand the logic,
Yeah.
you can use it for all sorts of problems.
Right, not just rotating matrices.
Exactly.
Okay, so we talked about how we could modify transpose and reverse to rotate counterclockwise. Does that same logic apply to these other two methods?
It does. It's all about changing the direction.
Okay.
So with layer by layer, we just swap the elements counterclockwise within each layer.
Okay, so instead of going right, we go left.
Exactly. And with cyclic replacement, we just change the order of our replacements.
Right, so we move things in the opposite direction.
Yep. Same steps, just reversed.
I see, I see.
It's amazing how, like, a small change
Yeah.
can make a big difference.
It is, it is. So we've covered 3 really clever ways to rotate a matrix,
We have.
all without using extra memory.
That's the key.
Yeah. So before we wrap things up, what are like the key takeaways here?
I think the most important thing to remember is that it's not about memorizing the steps.
Okay.
It's about understanding why the algorithm works.
Right, the concepts behind it.
Exactly. If you get that, then you can apply these ideas
Yeah.
to all sorts of problems.
Right, you can adapt them.
Exactly. It's like having a toolbox.
Right, and you've got all these different tools.
And you know how to use them.
Yeah, exactly.
Mhm.
So what about you? Any final thoughts or challenges for our listeners? It's all about practice, right?
Yeah. The more you practice, the better you get.
Like anything else.
Exactly. Now, I do have one final thought.
Okay, hit me with it.
So we talked about rotating 90 degrees clockwise and counterclockwise.
Right.
But what about 180 degrees?
Oh, that's a good one. So we'd be flipping the image both horizontally and vertically.
Yeah, basically.
Could we use what we've already learned to do that?
That's the challenge I want to leave our listeners with.
Ooh, I like it, a bonus challenge.
Think about all the techniques we talked about.
Okay.
Transposing, reversing, cyclic replacement.
Right.
Could you use those to rotate 180 degrees in place?
That's a good one.
Yeah.
I bet our listeners can figure it out.
I think so too. It's
Ah.
a fun little puzzle.
So to all our AI.Code.Cast fans out there, give that challenge a try.
Yeah, let us know what you come up with.
We love hearing from you guys.
It's awesome to see how you're using these ideas.
And that's it for today's deep dive into image rotation.
Thanks for joining us.
We'll catch you next time with another coding adventure.